In this lesson, we're going to graph and write equations of circles. But before we get to the circles, let's review a couple formulas that we've used before, or that I know that you've used before. One is the distance formula. So we're trying to find the distance between 2 points. D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. The other formula is the midpoint formula, and the midpoint formula is just that. It finds the exact middle of a line segment created by 2 points, or the halfway point between 2 points on a line segment. And basically, it's just the average of the x's and the average of the y's. We will be seeing these formulas from time to time when dealing with conics. So we're going to talk about a circle, and the standard equation of a circle with the center at the origin is simply x squared plus y squared equals r squared. So if that center is right there at the origin, it's simply that, where r stands for the radius. Okay, and each point on the circle is equidistant from the center, hence the definition of a circle. So let's graph one. When you're graphing circles or any conic, you'll be asked to identify certain features of it. In the case of a circle, we want to identify what the radius is. But before I can identify the radius, I need to write this in standard form. So I'm going to go ahead and add y squared. So I'll move the y squared over, so I say x squared plus y squared, and then add 4, like so. Now I want to label what the radius is going to be. And to find the radius, well, it's going to be r equals, and remember, 4 is for r squared. So I'll just say r squared is equal to 4. So therefore, r is equal to 2, because we're going to take the square root of both sides. Now, normally when we pull in a square root like that, we'd include plus or minus, but since we're talking about lengths and distances, negatives don't make sense. So therefore, the radius is 2. And that's something that you would box in. So now what we would do is we'd just start from the origin, and we can just lay in points north, east, south, and west as far as where the points are going to be from the origin. So each one's going to be 2 units from the origin. So I'll label one on each axis, actually 2 on each axis, like so, and then I will connect them in the best circular, fashion that I possibly can. Anyway, I'm going to cheat here and do it this way, and there's my circle. If you really want to be particular about it, this would be a good time to break out the old compass and make a really nice looking circle. Okay. In my next example, we have a point, 4, -7, and it lies on a circle whose center is the origin, and we're going to write the standard form of the equation of the circle. So in this case, we're just given a point, and we're told what the center is, and then we're expected to come up with the equation. So it looks like this. Generally, we just have a point somewhere out in space, and there is a point at the origin, and the distance between these points is going to be our radius. And simply, what is the equation of the circle that's going to, if we brought this all the way around, what's the equation of that circle going to be? So we'll probably, since we're looking for the distance of those 2 points, we're going to want to use the distance formula. So distance formula, we'll just substitute in our points where we're going to use -4 and -7 as our first point, but our other point that we're going to want to use is going to be 0, 0, which is going to be the origin. So thus I would just say, oh well, -4 minus 0 squared plus 7 minus 0 squared, and that's just going to simplify to -4 squared plus 7 squared, and really it's going to be around, have parentheses around them. And then we'll have the square root of 16 plus 49. And then that's going to be the square root of 65. So I don't need to find the square root of 65, but that distance is in fact going to be my radius. Okay, so instead of saying d equals square root of 65, I could just say r is equal to the square root of 65 all the way through. With that said, we want to now put this in our standard form of x squared plus y squared equals r squared. And since we know that r is equal to the square root of 65, r squared is simply going to be 65. So the equation is x squared plus y squared equals 65. And that's going to be the equation of our circle that goes through the point -4, 7. In the third example, we want to find the equation of a line that's tangent to the circle x squared plus y squared equals 61 at 5, -6. So this is not the actual solution it looks like, but this is a general idea. If you recall, a line that's tangent to a circle intersects the circle at a single point. Okay, like for example here. And there's a geometric property that states that any line tangent to a circle can be or is perpendicular to the radius. And we're going to use that fact to help us solve this problem by finding out what this slope is going to be of the radius, because we know what this point, we know what this point is, and we know that it's going to be at point 0, 0. So if you have 2 points, then you can find the slope, and then we're going to do that, find the perpendicular slope, because they do form a 90-degree angle. Okay, and then from there we can get the equation. We'll start off by finding the slope. So we have the point 5 and -6, and the other point's going to be 0, 0. M in this case is going to be slope, or we could use A. It doesn't really matter. I'm used to using A for slope for AX plus B or any of the other formulas. Anyway, so it's going to be, I'm going to do -6 minus 0. So the difference of the y's over the difference of the x's. So therefore, that's going to equal -6/5. And so therefore, a subperpendicular is going to be the, as you perhaps recall, the inverse reciprocal, or negative reciprocal, which is +5/6. So now that we have the slope and we have a point that's on the line, we can use point slope form and find the equation of the line. So it's been a while since we've used that, but it's going to be y minus y sub 1. So y minus y sub 1 equals a, in this case 5/6, x minus x sub 1 minus 5. So this simplifies to y plus 6. We distribute the 5/6, so it gives us 5/6x minus 25/6. And then we're going to subtract 6 from both sides, leaving us with y equals 5/6x minus 61/6. And we can leave it as an improper fraction. That'd be preferable. So that would be the line right there. That would be tangent going through 5, -6. I went ahead and graphed those already, so we can see here is the graph of x squared plus y squared equals 61, and then here is the line that we just found. And if I were to, we can see that right here is where that point where they intersect is going to be at 5, -6. One last thing, and I'm just going to kind of talk about this in general, is that we can talk about inequalities of circles. So if we replace the equal to portion of a circle with a less than sign, then we're talking about the inside of the circle. So if x squared plus y squared is less than r squared, then that's going to be inside the circle, that whole region. If we flip it around and say x squared plus y squared is greater than r squared, then that's going to be the region outside the circle, and that would be your solution area. So anyway, that's it. Until next time, I'll see you on the flip side.